Hey guys, we're back with the notes for 10.2. Graphing exponentials is something we've already talked about, so today we're talking about graphing a logarithmic function. Now, graphing logs is confusing, so I'm going to show you what it is, how it's created, what it means, and then I'm going to give you the 3-point shortcut for how to graph them, okay? All right, I'm going to have you start by pausing the screen right here, copy everything you see, we'll talk through it, and then I'll give you the shortcut. Perfect. So an exponential and a logarithmic function are inverses, which means if you notice the table, whatever was in the x column switches to the y, whatever was in the y column switches to the x's. You will notice that these graphs look like they are a perfect reflection over this equation, y equals x. So if I flipped it over this line, I would end up with the logarithmic function, okay? You'll notice that the pieces are very similar. So your domain being all real numbers, now it's your range. Now it's the y values. Let me highlight that real quick. My range being from 0 to infinity would mirror, and now that's my domain. My x and y pieces switched. Just like I had a horizontal asymptote at y equals 0, now I have an x equals 0 asymptote. That's a vertical. Just like I had a y-intercept at 0, 1, now I have an x-intercept at 1, 0. All of my pieces are flipping. That's what the basic understanding of exponential and logs are. They have the same base, so 2 to the x would mirror with log 2 of x. This is essentially, let me label him, this would match our base, okay? So if I was going to give you a different comparison, I could do y equals 3 to the x would be the inverse of y equals log 3 of x. They are inverses of each other if they have that same base, okay? All right, all that being said, that is not how you will graph a log. You will not graph an exponential, switch all the pieces, and then graph it. It just would take way too long to do that. So here's what I need you to know. These are the 3 points that every log graph has. You are going to try for 3 different things. You are going to try to make your parentheses 0, 1, and a. If you will copy those down, we'll get started. Perfect. Okay, so if you are making your parenthesis 1, no matter what your a is, the whole value will equal 0. If your parenthesis is equal to 0, whatever the transformation makes it equal 0, you automatically have a vertical asymptote at wherever that x value is, okay? Finally, if your base and your parenthesis match, doesn't matter what a is, if they match, your value is automatically a 1. So we're going to keep that in mind of trying to figure out what makes the parenthesis 1, what makes it 0, what makes it a, and that's how we're going to get our 3 points. Okay. I will do additional problems at the end. If you would like to copy them down, you can. The only ones I'm requiring to get the notes grade is these main 4. Okay. All right, so let's start with the first one. If I'm going to graph the comparison between 10 to the x power, that means I am going to raise it basically 3 times. I'm going to plug in -1 as his exponent. That's 1 over 10. Plug in 0 as his exponent. We know that gives us 1. Plug in 1 as the exponent, that gives us 10. So graphing this guy, basically I end up with my normal y-intercept, I end up with my b value, I end up with my invert, and that is going to be a very, very, very steep graph, with an asymptote on y equals 0. So I could do the exact same idea and invert that and say, okay, well now my asymptote, because those are both a base 10, I know my asymptote is going to switch to x equals 0. I know that I'm going to end up with, instead of 110, I'm going to end up with 10, 1. Instead of 0, 1, I'm going to end up with 1, 0. And instead of -1, 1/10, I'm going to end up with 1/10, -1. Okay? This is my graph. Now, how would I get that without doing an inverse? Let's come over here. If this is my equation, these are the things I'm looking for. First goal is to figure out what would make my parenthesis a 0. So my parenthesis is this part. Well, if x was 0, then I would have a vertical asymptote. That means my asymptote's at x equals 0. Second thing is if I could make my parenthesis be a 1. Well, that's easy. I just make x a 1. That means my point is 1, 0. We already graphed that. Finally, my last goal is to make it the same as the base, which is a 10. How would I make that a 10? Well, I just make the x a 10. He is the parenthesis. That's where my last point came from. Okay? All right, so in this graph, I would really only need 2 points and the vertical asymptote to understand where my graph shape is. Let's go ahead and fill in the rest of our pieces. Remember that these should be similar. Your domain and ranges are switching. Range in this case is going to be from negative infinity to positive infinity because I'm going up and down forever. The domain is going to look very similar to the range on the exponential. So he's going from 0 all the way to infinity on the right. My asymptote is now vertical at x equals 0. And my x-intercept is the switch. He is 1, 0. Okay, if you need to pause anything on this top problem, do that now. And then we'll talk about the bottom. All right, we are going to be looking at the graph e to the x. E is a number like pi. It's a long decimal. It never repeats. It never terminates. You just need to know it's about 2.7. Okay? So if I plug in a -1, I'm basically doing 1 over 2.7, which I rounded off for you already. It's on the table. If I plug in 0 as the exponent, I obviously get 1. If I plug in 1 as the exponent, I get my e value, which is 2.7. We're going to go ahead and graph these. At -1, I have a small decimal. At 0, I have 1. And at 1, I have 2.7-ish. So just somewhere between 2 and 3 gives me enough. I'm going to go ahead and draw my graph. No transformations on this guy means that my asymptote is still on 0. So if I fill those in, it should look like this. From negative infinity to positive infinity for my domain. Range is from 0 to infinity. It's above the asymptote. Asymptote's on y equals 0. Y-intercept is 0, 1. Okay. Now, we can go through the same idea of inverting every single point, or we can use our 3-point shortcut. So again, if I walk you through this, you're going to have 3 goals. Your first goal is to get your vertical asymptote. That means making the parenthesis equal to 0. Very easy. That's going to be 0 because my x is in basically the parenthesis by himself. Doesn't even matter what the base is. I'm going to have a vertical asymptote at 0. Second goal I'm going to do is try and get my parenthesis to equal 1. Well, the x is by itself, so that's automatically a 1. Last goal is to get the base to match what would be in the parentheses. And in this case, my base is e. So we can either write e or you could do 2.7, which is what I'm going to do. Okay. All right, let's go ahead and graph those points. So we're going to graph 1, 0, and we're going to graph 2.7, 1. I can't really do much else. I am going to have a vertical asymptote, though, at x equals 0. Okay. All right, again, you'll notice that all the pieces are switching. So my range this time is going to be all real numbers. My domain is going to be from 0 to infinity. It's going to the right. Asymptote switches to x equals 0. And my x-intercept switches to 1, 0. Now, again, not on your homework. You're not going to be graphing the exponential and the log right next to each other and just getting to copy all of those. So do remember your rules for how to get domain and range, your asymptotes, and your x-intercepts. Okay? All right. If you feel like you got it enough to try the practice, go for it. If you feel like you would lose your mind having to do this with transformations, then I suggest you copy the bottom 2 problems down and work these with me. These are for extra help if you need it. Okay? All right. So I wrote out 2 problems that do look similar to questions that you're going to have on your assignment, and I want you to keep your goals in mind. Okay? So these are the 3 goals. Your vertical asymptote is whatever would make the parenthesis equal to 0. Let's talk about both of these because there's transformations going on. In this problem, if I look on the first one, to make my parenthesis equal to 0 means that x would have to be 0, and that's great. But you can't forget the transformation. So if right now I have an equation, a vertical asymptote at x equals 0, and I shift that vertical asymptote up 2 spaces, does it change? No. A vertical shift will not impact your vertical asymptote. So my vertical asymptote stays, x equals 0. Now, when I go to this next one, when I have a y value, it will impact it. So how do I make the parenthesis a 1? X is by itself, so he is a 1. But I don't land on 0 now because there is a vertical shift. So now my value moves to 2. My point then is at 1, 2. Okay. Last goal is to make your parenthesis match your base. So that means I would have to make my x a 5. But I end up with a y value, and I have to do a vertical shift on it. That gives me 3. So I'm adding this 2 every time that I get a y number. Now my point is not 5, 1. It's 5, 3. Okay. All right, so I would need 2 points and the vertical asymptote to graph that guy. Okay. Let's go to another one. So that's how to work a vertical shift. This one's got a lot going on here. So I've got a vertical stretch out front, and I also have a horizontal transformation going on in here with the x. So let's start with this one. For the purple, if I'm trying to make log base 3 of something, I'm trying to make that equal 0. What would the x have to be so that the purple part is 0? Well, the x would have to be a 1. At that point, that tells me where my vertical asymptote is going to be. A vertical stretch, this 2, he's not going to do anything to my vertical asymptote. If I took this and I stretched it twice as tall, it doesn't change where it's located. Let's delete him, sorry. So my vertical asymptote doesn't change, but now it's at x equals 1. It's whatever this number was. Okay? Let's go to the next part. If I'm trying to make the parenthesis a 1, well, what minus 1 would make a 1? I would need my x to be a 2. You with me? I'm trying to make the purple piece equal 1. So I'm basically saying x minus 1 equals 1. Think about how you would solve that. That means my x has to be a 2. All right, now that we know that x is a 2, don't forget that we're doing a vertical stretch. So I'm going to multiply this by 2. Multiplying by 2 on a 0 doesn't really do anything. It's still going to be 0. So my point stays 2, 0. Okay. All right, third goal. You were trying to get the parenthesis to match the base. So I'm trying to get x minus 1 to equal 3, which is my base. If I add 1 to both sides, my x would have to be a 4. So the 4 as my x value would make the purple match the base. Okay? That in mind, that gives me a 1 for my y value. But there is a vertical stretch. So I'm doing this part now. Multiply him by 2, gives him a 2. My point is not 4, 1, it's 4, 2. So I have a vertical asymptote on 1, and then I have these 2 points to graph with. Okay? I would highly, highly encourage that you try to work the tables on this assignment by yourself before you get to class. That way I can help troubleshoot anything you're having a problem with for those before you even start making the graphs or the asymptotes or anything going on. I would see if you can get those 3 values to work for every problem. Okay? All right, if you missed anything on here, go ahead and listen to it again. Otherwise, we are done with 10-2 notes.